Guys, welcome to Science and Faith. In this video, we're going to talk about the Theorem of Pythagoras, Part 1. Well, the Theorem of Pythagoras states that in any right-angled triangle, the square of the longest side equals the sum of squared perpendicular sides. Suppose we have a triangle like this with a right angle. Our business is to first identify where the longest side of this triangle is. Well, the longest side of any right-angled triangle is always the slanting side. Or you could say it is the side opposite the right angle. Then the other two sides that are at 90 degrees to each other are termed the perpendicular sides. To be able to apply the Theorem of Pythagoras, we need to be able to identify the longest side and the two perpendicular sides. Using a system of letters, suppose the longest side is C, the perpendicular side is A, and the other perpendicular side is A. The Theorem of Pythagoras can be stated as C squared equals A squared plus B squared. So whenever you're dealing with problems involving the Theorem of Pythagoras, your important step is to identify where this longest side is, where the two perpendicular sides are. The longest side is termed the hypotenuse side. Okay. Calculate the lengths of the missing side marked X in the diagrams below. In diagram 1, we've got a right-angled triangle with three sides. Where is the longest side? It is the slanting side, the side marked X. And the side marked 8 units and the side marked 15 units are the perpendicular sides. Applying the Theorem of Pythagoras, we end up with x squared equals 8 squared plus 15 squared. 8 squared is 64, 15 squared is 225. We add the 64 plus the 225, we end up with 289. From here now, all we have to do is to get the square root of the two sides. And this will give us x equals 17 units. Diagram 2, the triangle is placed differently, but it doesn't matter, because we can see clearly where the right angle is, meaning the side marked 5 and the side marked X are the perpendicular sides. The side marked 13 is the hypotenuse. We can now apply the Theorem of Pythagoras. The 13 squared is equal to the 5 squared plus X squared. We solve for X squared. 169 equals X squared plus 25. At this stage, we now subtract 25 from both sides. And then we end up with x squared equals 144. Again, we now need to take the square root of both sides. We end up with x equals 12 units. In this diagram, we've got an interesting scenario because we can clearly see the slanting side is 28, that is the longest side. The perpendicular sides are both marked X. So we can apply the Theorem of Pythagoras. 28,28 squared equals x squared plus x squared. Like terms can be added. We end up with 2x squared equals 799,7584. The next step is to divide by 2 so that we remain with the x squared. So these 2 will divide 2, will remain with 1. Then we get x squared equals 399,89792. Last step, square root of both sides, and we end up with our answer of x equals 19,997. If we were to round off to one decimal place, x equals 20 centimeters. Think you guys have got it? Well, it's practice time. Grab your pens. Calculate the length marked y in the following triangles, correct to one decimal place. So you'll be given about 30 seconds before the answers start appearing on the screen. If you feel you need more time, well, just press the pause button, and when you're ready to check your answers, press play again. Okay, here are the solutions. Triangle A, the hypotenuse is 25, the perpendicular sides are 15 and y. Applying the theorem of Pythagoras, 25 squared equals y squared plus 15 squared. We need to subtract 15 squared on both sides to leave the y squared alone. So 25 squared minus 15 squared is now equal to y squared. Take the square root of both sides. So the square root of 25 squared minus 15 squared is now equal to y. And then we can now use a calculator. We get an answer of y equals 20 centimeters. Diagram B, we can clearly see that y, or the side marked y, is the hypotenuse. Applying the theorem of Pythagoras again, y squared equals 75 squared plus 100 squared. Take the square root of both sides. Y is equal to the square root of 75 squared plus 100 squared. This will give us y equals 125 centimeters. Diagram C, we've got a square, so which means the four sides are equal. So this side here is also y, this side there is also y. The diagonal is 100 millimeters, so the perpendicular sides in this case are the sides marked y. Applying the theorem of Pythagoras, 100 squared is equal to y squared plus y squared. So 100 squared is now equal to 2 of y squared. Divide both sides by 2. 100 squared over 2 is now equal to y squared. So this side is now being divided by 2. Okay, let me just do that. So we ended up with 100 squared over 2 is now equal to y squared. So we can take the square root of both sides, and we get y is equal to 70.7 millimeters. So there you go, guys. That's how you could apply the theorem of Pythagoras. Step 1, identify which side is the hypotenuse. Step 2, write down the theorem of Pythagoras in terms of the squared sides. Step 3, substitute the known values and work out the unknown value. Thanks for watching, guys. See you next time when we extend the idea of Pythagoras further and tackle even more interesting problems. Thanks for watching.